Yes, ma'am.
I think I have shared the NMR PPT. NMR का PPT मैं भेजती हूँ ना आप लोग को. NMR से मैं इतना पढ़ाऊंगी just how to like calculate how you will know that how many signals you will get in a compound.
एक्सक्यूज मी मैम.
यस
मैम हमारा कितना क्विज होगा थियरी में?
एग्जैक्टली पता नहीं, सारे चैप्टर से एक एक क्विज होना चाहिए.
तो हमारा तो मतलब एक हो चुका है और एक
नहीं हुआ है, 2 हो चुका है. ये थर्ड क्विज आई थिंक.
मैम एक हुआ था ना पहले, एक ही हुआ था.
मुझे लग रहा है 2
हो चुका है ना.
ये थर्ड क्विज होगा. इसके बाद फिर स्पेक्ट्रोस्कोपी से एक क्विज होगा.
मैम मतलब हम लोग का थ्योरी और प्रैक्टिकल दोनों का होता रहेगा. थ्योरी में हम लोग का एक ही हुआ है.
थ्योरी में एक हुआ है.
यस मैम एक ही हुआ था.
थ्योरी में एक ही हुआ है और लैब का
जितना हो सकता है उतना करेंगे. मुझे लग रहा है सारे टॉपिक को कवर करेंगे. Okay, so without wasting our time, let's start.
थ्योरी में शायद 2 हुआ है मैम.
मुझे भी लग रहा है 2 हुआ है.
एक एंट्रोपी तक हुआ था, एक एंट्रोपी के बाद हुआ था. 2 हुआ था.
हाँ 2 तो.
आई गेस फर्स्ट वाले का मार्क्स नहीं मिला था. मार्क्स 1 का ही मिला है.
फर्स्ट वाले का नहीं मिला.
यस मैम सर ये हो सकता है.
Yes, ma'am. We didn't get the first result.
मिला था हमें.
Let me ask. It's okay. At the end, you will get everything because before sending to the for your grading, we have to send to the examination cell. Before sending to them, we have to discuss with the students. So, like at that time, they have to give us all the quiz marks, whatever taken centrally, and the marks what I feel during the like assignment. It is mid-sem like marks is only 20 and we have to give another 30 marks. So that 30 marks is from the quiz and assignment. Okay. So from quiz and assignment we have to add, they have to give, otherwise how can we add without knowing the marks of the students? Okay. So for that they have to give and they will give. So without wasting our time, let's discuss IR spectroscopy. We are already discussing that selection rule of IR spectroscopy, which molecules will be IR active and which molecules are not IR active. And again, you know that the degrees of freedom are the sum of the translational, vibrational and rotational degrees of freedom, that is 3n, and For linear molecules, it is the translational degrees of freedom is 3, rotational is only 2, and vibrational will be 3n minus 3 plus 2 is equal to 5. Okay, for linear molecules, number of vibrational degrees of freedom okay, and here n is the, what is n here? Number of atoms. Just for example, carbon dioxide. Okay, in carbon dioxide, it is a linear molecule, you know. So the number of vibrational degrees of freedom is equal to 3n minus 5. So 3 into 3 minus 5 is equal to 4. Similarly, CH4, it is a linear or non-linear molecule? CH4 is linear or non-linear?
Non-linear.
So 3n minus 6. 15 minus 6 is equal to 9. So if you will get questions to find out the number of degrees, vibrational degrees of freedom, you can calculate. So next we'll discuss vibrational frequency, which we plot in a graph, or in the form of graph you will get from the instrument, vibrational frequency.
Excuse me, ma'am.
हाँ
मैम थोड़ा ऊपर स्क्रॉल कर दीजिए ना. Thank you, ma'am.
1 by 2 pi c k by. Okay. So this is the frequency of vibration. Here, this is the frequency of vibration. Okay. In centimeter inverse, and K is the force constant. Reduced mass, which is equal to m1 m2 by m1 plus m2. So m1 and m2 are the atomic masses. So you a generalized statement for CX, when it is a single bond, it is 1200 centimeter inverse, the vibrational frequency. When C double bond X, it is 1600, and when C triple bond X, it is 2200 centimeter inverse. Here X may be C, N, etc. Okay, so you have to remember few of the values. When it is C double bond O, C and N, C double bond C, N double bond O. So the peak will be at 1500 to 1900 centimeter inverse. Okay. So when it is a single bond, CH, NH, OH, it is 2700 to 3800 centimeter inverse. Can you please tell me why the double bonds means like as compared to the single bond has less frequency? Can you tell me? So it depends on the bond strength. Okay? It depends on the bond strength. How much energy is required to vibrate the molecule. Okay, so these are the few values. And you have to remember the conjugation lowers the stretching frequency. So as in the case of UV, the conjugation increases the lambda max value. Here it decreases. Okay, just for example, the IR value means like the peak for this compound CS3, CO, CH2, CH2, CS3. So here this carbonyl will, the stretching frequency of this carbonyl is at 1720 centimeter inverse. This is the significant peak or the characteristic peak for the carbonyl group. But in the case of this one, this compound, although it is also a carbonyl compound, here it is 1680 centimeter inverse. Why it is 1680? Here it is 1720, but here it is 1680. It decreases because you know the double bond has require more energy to vibrate as compared to the single bond. So here it is no longer it is a double bond when it is in the resonate form, sorry. So here it is in the resonate form. So it will be like this. So C double bond O became now C plus O minus. So it is just no longer a double bond. It is only a single bond. That's why the frequency of absorption is less as do you understand why the conjugation lowers the frequency? Actually, I was teaching ORD and CD to MSc students, so this is there. Okay. Any doubt for this one? Am I audible?
Yes,
Because I'm looking at the screen, I'm not able to see you all. Okay.
मैम एक बार फिर से बोल दें.
ये है कि आपका जब यहाँ पे कोई conjugation नहीं है, इसका frequency 1720 means which is higher. But here there is a conjugated system. This is a conjugated carbonyl system. This double bond is taking part in the like conjugation or the resonance form. So the double bond is no longer a double bond, rather than it is a single bond in the resonate form. That's why the frequency is 1680 centimeter inverse, which is less than the 1720 centimeter inverse.
Yes,
is it okay? Is it okay?
Yes, ma'am.
Okay. Then the S character, if the S character increases in a bond, the bond becomes stiffer. Okay. So the S, if you will compare with the sp hybridized system, that is more stronger than the sp3 hybridized carbon-carbon bond. Okay. So if we'll just check in higher frequency, C triple bond C is, so it is sp hybridized, the stretching it at 3300 centimeter inverse. Okay. But when it is sp2 C double bond C H, then it is sp2 hybridization, that is 3100 to 3100 to 3020 centimeter inverse. Okay, if it is only sp3 C single bond CH, it is at 29602 2850 centimeter inverse. Just a comparison, if we'll see, if it is a single bond, it is lesser, double bond, it is little bit more, but in case of triple bond, when the bond become more steeper, more stronger, then the frequency of absorption is also more. Is it okay?
Yes, sir.
Okay, then the competition between inductive effect and resonance effect sometimes becomes important in deciding the magnitude of stretching frequency. Okay, just for example, RCO OR and RCONS2. Okay, so this is 1735 centimeter inverse. Here it is 1660 centimeter inverse. So here you can say this is resonating structure, but here it is inductive effect. Okay, so here you can say in ester the inductive effect is predominant over the resonance effect. That's why the frequency of absorption is more. Do you understand? Do you understand?
मैम एक बार वापस बोलेगा.
एक्चुअली जहां पे इंडक्टिव इफेक्ट भी पॉसिबिलिटी है और रिजोनेंस भी है. ठीक है, इंडक्टिव इफेक्ट आपको पता है जितना हाइड्रोजन नंबर ऑफ हाइड्रोजन्स आर अटैच्ड टू द सिस्टम, है कि नहीं? जैसे CH3 HH एक इंडक्टिव इफेक्ट आपको पता है या नहीं?
यस मैम.
तो अगर दोनों है तो जो प्रीडोमिनेंट है तो उसी के हिसाब से आपको डिसाइड करना है कि फ्रीक्वेंसी क्या होगा. और ये भी है, विद द इंक्रीज इन द रिड्यूस्ड मास द फ्रीक्वेंसी ऑफ वाइब्रेशन डिक्रीजेस. मतलब आपको रिड्यूस्ड मास है m1 m2 by m1 plus m2. जस्ट फॉर एग्जांपल CH and C and CH. तो यहाँ पे म्यू इज इक्वल टू m1 m2 by m1 plus m2. Here m1 is the mass of the carbon, another one is m2 is also mass of the carbon. But in case of this one, m1 m2 by m1 plus m2, so here the mass of hydrogen and carbon. One is carbon, one is hydrogen. So as the reduced mass increases, the frequency of vibration decreases. So it is 1200. The frequency of vibration is 1200 centimeter inverse, and here it is 2800 to 3000 centimeter inverse. Sorry. Okay, so here the reduced mass will be more because the mass of carbon is more as compared to hydrogen. That's why the reduced mass will be more in case of carbon and carbon. Okay, so that's why the frequency is 1200 and here it is 2800 to 3000. Is it clear? Or you cannot also exactly say C and CH and OH. So here the reduced mass, there is a slight change, increase in the reduced mass. In some cases, the frequency of vibration also increases with a slight increase in the reduced mass. In case of OH, it is 3300, but here it is 3000. 3300 centimeter inverse, but here it is 2800 to 3000 centimeter inverse. So although there are some cases, although the reduced mass little bit increases, still the frequency of vibration also increases. I'll give you one question. Calculate, this is the last part of IR spectroscopy. Calculate the wave number of stretching vibration of a carbon-carbon double bond. The force constant is given 10 to the power 6 dyne per centimeter. Calculate. Please calculate the force, like the wave number of stretching vibration. Can you calculate or not?
I'm trying.
Please try.
Ma'am,
Yes.
is it 21.66 into 10 to the power minus 10?
No.
Ma'am, 1680.
Yes. 1680 is the correct answer. Simple. Mu bar is equal to, first of all, you have to calculate the reduced mass mu, that is equal to m1 m2 by m1 plus m2. So m1 m2, like the mass of carbon, you have to just add and multiply. So m1 m2 is equal to 12 into 12 divided by 24. Okay, so how much you got? 6 mu. So mu 2 gram, you have to, how much you have to multiply to make it atomic mass unit 2 gram? How can you convert mu to gram?
By multiplying
1.66 into 10 power minus 24.
So then you have to put the formula mu bar is equal to 1 by 2 pi c root over of k by mu. Okay?
Yes, ma'am, got it.
So just remember 1 mu is equal to 1.6 into 10 to the power minus 24 gram. Here IR spectroscopy is completed. Now we'll start NMR spectroscopy. So this much means UV and IR. The important part I'll just summarize. In UV you have to know why the UV spectra is broad in nature and Beer-Lambert's law. Some numericals related to Beer-Lambert's law. Then types of transition with example, and then Woodward-Fizer rule. To calculate theoretically, you will calculate the lambda max value for some of the organic compounds. So these are the important part of UV spectroscopy, as well as some of the terminologies like oxochrome, chromophore, bathochromic shift, hypochromic shift, hypsochromic shift, hyperchromic shift. So these are all about the UV spectroscopy. And then also you have to remember what is vacuum UV region. And in IR spectroscopy, the fingerprint region. Okay, selection rule and exceptional in case of carbon dioxide, calculation of vibrational degrees of freedom and calculation of frequency, vibrational frequency, a basic knowledge about the factors affecting the vibrational frequency, just like the conjugation and inductive effect, resonance effect, the S character in the bonding. Okay, so these are the basic things, and then we'll start NMR spectroscopy. In NMR spectroscopy, it is just like overall toss to the spectroscopic technique, because more details are there. Still, we are not teaching in the BTech level. Just these are the techniques by which you will characterize your compound. Okay, so basic characterization techniques. And in NMR spectroscopy, in medical technology, there is one technique is used to diagnose, for the diagnosis, that is MRI. Have you heard this name before? MRI, magnetic resonance imaging. Even if any local hospital you will go, or local diagnostic center you will go, you will get MRI machine. Although it is a costly machine, it is required to know the deformation or anything, more clear image in the brain or some tissue level. Okay, but whatever means basic information you will get from X-ray, and little bit more complex information you will get CT scan, and more detail you will get from MRI. Is it clear?
Yes, ma'am.
Okay, so MRI is a machine that is based on NMR. The basic principle is same. So you can say that the application of NMR spectroscopy in medical technology is MRI. Okay, so here the basic principle is same in both the instrument, and both are they work in the radio frequency region. One thing you never forget that in spectroscopy, it is the interaction of light with your sample to give some information about your sample. Maybe the sample is a human being, maybe the sample is an animal, maybe the sample is just a chemical compound. Okay, so the interaction of matter or sample here, the sample may be different. Okay, human being is the sample at the time of diagnosis. Do you understand now? Okay, so we are getting the information about the human being of a particular organ. Means like if I am getting pain like in my shoulder and it has to be diagnosed, what is the problem in the nerve region, why I am getting the problem or getting the pain. So here I am the sample for that in that particular experiment. And the spectroscopic technique is MRI. It is a MRI machine, but the spectroscopic technique, the basic principle is NMR. Okay, so that is we are just the end user. We do not understand the principle. We do not understand how it works, but we are just getting the information, and doctors, they cannot understand too. Okay, they will just switch on, switch off, and then get the information and just analyze it for what should be with the healthy human being and what happened to this particular patient. So they will just compare. If there are some differences, they will just correlate what could be the problem. Okay, so the same way in NMR we can get how many signals we can get for a particular compound. Just for example, methanol and ethanol both are given in a test tube. Like in two different test tubes, one is ethanol, another one is methanol. Even if one is ethanol, another one is, like you can say, some liquid beverage. Okay, so maybe some alcohol beverage. So if I'll give to one of my students to distinguish which one is what, with his or her naked eye, he or she cannot understand who is compound, what is the liquor it is in the test tube. Okay, so it is really difficult. We cannot distinguish it with our naked eyes. We have to take the help of spectroscopic techniques. Okay, so NMR is the spectroscopic technique by which we can know how many carbons are present in that particular compound, how many hydrogens are present, even if 31p, 19f. So those things I am not discussing with you all. Only we are discussing proton NMR. Okay, 13C carbon NMR is not in your syllabus. So we can know how many protons are in that particular compound. So once you will know the skeleton, you will definitely know what is the compound is. Okay. Just for example, CH3OH and C2H5OH, and I'm putting in two test tubes. Okay, so both are colorless and odorless. You can odorless, if there will be a little bit odor also, it is not wise to always smell the chemical compounds. Okay, and I'll show to my students which test tube contains which liquid. Can you say me which one is what? Without any test, any characterization? Anybody can say? Anybody is having divine eyes?
No, ma'am.
No, we cannot say. Because both are liquids, both are colorless, and it is difficult to distinguish. But in NMR techniques, NMR machine, if we put the samples, then we can know which one is what. How will know? Because in NMR, the protons in a particular chemical environment, they will show a single peak. Okay. In methanol, how many types of protons are there? How many types of protons are there? If I'll write it like this, I think it will be easier to distinguish how many types of protons are there. How many types of protons are there? How many types of protons are there? How many types? These all are A-type proton and here it is B-type proton because they are all connected to carbon. Here it is connected to oxygen. It is more electronegative as compared to carbon. So this chemical surrounding of this proton is different as compared to this proton. Is it making any sense? Is it okay?
मैम एक बार वापस थोड़ा बोलिएगा ना।
देखो ये जो प्रोटॉन है यहाँ पे जो हाइड्रोजन अटैच कार्बन के साथ यहाँ पे हाइड्रोजन अटैच विथ ऑक्सीजन। ओके, ऑक्सीजन इज मोर इलेक्ट्रोनेगेटिव, आपको ये पता है ना?
यस मैम।
कार्बन के तो यहाँ पे जो हाइड्रोजन बॉन्डिंग है, यहाँ पे जो हाइड्रोजन का एनवायरमेंट है ये डिफरेंट एज कंपेयर टू दिस वन, है कि नहीं?
यस मैम।
तो ये एनएमआर में ये तीनों मिलके एक सिग्नल देंगे और ये एक सिग्नल देगा, तो हम लोग को पता चल जाएगा कि कौन सा क्या है यहाँ पे। लेकिन ये प्रोटॉन एक एनवायरमेंट का, ये दोनों एक ही एनवायरमेंट का। ये here we will expect 3 peaks, here we will expect 2 peaks. So from this one we can distinguish which one is ethanol and which one is methanol, क्योंकि हम लोग को इस बार बोले हैं कि लेकिन एनएमआर में जस्ट नंबर ऑफ सिग्नल्स आप लोगों को कैलकुलेशन सिखाएंगे, नॉट मोर देन दैट।
एनएमआर का फुल फॉर्म क्या है?
न्यूक्लियर मैग्नेटिक रेजोनेंस। न्यूक्लियर magnetic resonance. Just a minute, I have to talk to one of our colleague that what we will cover in NMR. Just a minute. I'll give you some questions. In the meantime, you will try to find out how many signals will be there. I'll just talk to her. How many signals you will expect here and how many signals you will expect here. Let me give you some questions. You try to find out. She should answer my call. She has 3 ways. Calculate the number of signals. Not picking. Just a minute, let me try with. Nobody is picking my call. What happened? Everybody is busy in class. Just calculate the number of signal. This much only, or any theory part too we have to teach. Means I don't think that theory part will be included in your exam. भाई नमस्कार। अच्छा, जो एनएमआर रे पिला को खाली नंबर ऑफ सिग्नल्स पढ़ाबो तो आउ थ्योरी माने डाउनफील्ड अपफील्ड केमिकल शिफ्ट एगुडा पढ़ाबर नै तो सिल्डिंग डिसिल्डिंग कोन आमे पर प्रिंसिपल पढोने मु जानि नै ठीक रे मते सेटा जानवर अछि। मु एबे नंबर ऑफ सिग्नल सारे देगी तांको पूरे सीधा पढी दोची नानो मटेरियल तापर इलेक्ट्रोकेमिस्ट्री पढोते जदी इन द मीन टाइम जदी किसी दरकार पड़ले पिला में एक्स्ट्रा पढिथिबे ने कोन आ कोन किछि इन्फॉर्मेशन अछि कि नै किछि माने मु सोहिनी के फोन करथिली तो कहीं फोन उठेले मैडम। Okay, this much only. In the meantime, if it is required anything else, I'll tell you. But here, I think only number of signals, if you can able to calculate, then that is more than enough. Okay. In the then we'll start nanomaterials. This will not take much time. Then last topic, it is your electrochemistry. Another, how many classes will get for chemistry? Are you able to calculate? How many signal you will get in methane?
1.
Students? Very good. Correct answer. And in case of acetone?
3.
Ma'am, 2.
No.
Ma'am, 1.
No.
Ma'am, 1.
Ma'am, 1.
Yes, 1. Then next compound, it is 1. It is 1. 1 signal. Because it is A type proton, this is A type, it is a same chemical environment means 1 signal. Here, how many signal you will get?
Ma'am, 3.
3.
3 signals, correct. How many signals you will get here?
Ma'am, which one?
1.
1, ma'am.
No.
Ma'am, 2.
Very good. Here 2, because 2 type of proton. Here 1 ion, and here also 1 type of proton. Okay. How many signals you will get in ethene?
1.
1.
1. How many signal you will get in methanol?
2.
2.
2. How many signals you will get here?
2.
1.
Butylamine 2. Still confusion. Some more question will you solve? CH3.
Ma'am, can you explain once how to find out the number of signals?
Just remember one thing. Same chemical environment. One signal. Okay. Different. Like how many different chemical environment? Different. That type of like that many number of signals you will get. Just for example, in methane, all the hydrogens are connected to carbon. So the chemical environment is same for this hydrogen, this hydrogen, this hydrogen, and this hydrogen. So that's why you are getting only 1 signal. Is it clear?
Yes, ma'am.
In case of acetone, CH3CO, CH3, all the protons are connected to carbon. Here also carbon. Okay, so this part is not containing any carbonyl system. If you just expand it, it is like this. Okay, so here all the hydrogens are in the same chemical environment. So they will have only 1 signal. Is it clear?
Yes, ma'am.
And here in this case, CH3, CH2, NH2. Okay. So here these protons are different than this proton and different than this proton. So the protons which are directly attached to nitrogen, they have a different chemical environment as compared to this proton, because this carbon is connected to nitrogen and here the carbon is connected to another 1 carbon. Okay, so the protons which are attached to this methyl proton, means the 3 protons which are connected to this carbon are different than the protons, 2 protons which are connected to this carbon, and again different than the protons connected to nitrogen. So all the 3 type of protons are present in this compound. So 3 different peaks you will get in NMR.
Okay, ma'am. Got it.
Okay, got it. So this is all about NMR spectroscopy. That's like this much only I'll teach you. And this much you like prepare for your examination. NMR, you will get some chemical compound. You have to find out how many signals you will expect for the compound. If it is cis and trans at that time, it is also different peaks you will get. Okay.
Excuse me, ma'am.
Yes.
Ma'am, can you send some question of that lambda max value on that?
Yes. I'll give. Okay. So next is your nanomaterials. Okay. In nanomaterials, do you have the syllabus? Nanomaterial syllabus. I think I have already said. Nanomaterials. I think I have already shared the syllabus, the topics what we will discuss in nanomaterials. What happened? All are silent. Nanomaterial syllabus, do you have or not? Students, do you have nanomaterial syllabus or not? I think I have shared with you all.
देखना पड़ेगा देख के बता रहे हैं।
Nanomaterial, yes. Classification of nanostructured materials, synthesis of nanomaterials. The synthesis techniques are CVD, wet chemical synthesis, GPC, CBC, and PLD, and some of the applications. So first of all, what is nanomaterials? Classification of nanomaterials, then synthesis of nanomaterials. In the synthesis procedure, CBD, wet chemical synthesis, GPC, CBC, and PLD. But here only 1 or 2 methods is enough. CBD will discuss and wet chemical synthesis. Then application of nanomaterial, this much only. Okay? I'm sharing the screen. Is it visible? Chemistry of nanomaterials, the syllabus. Is it visible? Chemistry of nanomaterials?
Yes, ma'am.
Yes, ma'am.
First of all, introduction to nanomaterial, classification of nanomaterials, synthesis of nanomaterials. So how we can synthesize the top-down and bottom-up approach, and some of the specific techniques, CVD, wet chemical synthesis, GPC, CBC, and PLD methods, and the application of nanomaterials, especially CNT, graphene, and fullerene. Okay, so basically here we are discussing the nanomaterial based on carbon, not the metal systems. Okay, so nano means dwarf. Okay, it is the Greek word like nano, and the nanometer, you know, 10 to the power minus 9 meter is the scale. If the materials are in this range, then only we can say these are the nanomaterials. Okay, so the nanomaterials, you know, nowadays everywhere you will get the application of nanotechnology, starting from beauty products to the vehicle. Everywhere you will get the application of nanomaterials. Okay, so there are different types of nanomaterials. I think nanomaterials PPT I have shared with you all. So based on the materials, composition, nanomaterials are different type. Carbon-based nanomaterials and metal-based nanomaterials, dendrimers and composites. So here only we'll discuss carbon-based nanomaterials. So carbon-based nanomaterial, based on their size, there are different types: 0D, 1D, 2D, and 3D. Okay, so carbon dots are 0-dimensional, and 2-dimensional are graphene sheets. Okay, 1-dimensional are nanotubes, and 3-dimensional are graphite and other structures. Okay, so these are the different types of nanomaterials. I think do you have the PPT, or shall I because this theory part shall I write or what? Do you have the PPT? Please check it. I think I have shared. Students, please check. Otherwise, how you will prepare for your examination?
एक मिनट चेक कर रहा हूँ।
हाँ, चेक कर लो। अगर नहीं है तो फिर मुझे मतलब थोड़ा बहुत लिख के देना होगा, क्योंकि इसमें ज्यादा कुछ नहीं है, थ्योरी है, जस्ट रिमेम्बर करना है। आप देखो, बॉटम अप अप्रोच, टॉप डाउन अप्रोच। टॉप डाउन मीन्स एक बड़ा चीज को छोटा छोटा करके तोड़ना है, ठीक है ना। और बॉटम अप मीन्स लार्जर मॉलिक्यूल को छोटा करना है, नानो फॉर्म को लाना है, तो टॉप डाउन। और बॉटम अप मतलब छोटा छोटा मॉलिक्यूल को नानो फॉर्म को लाना है।
मेरे को रीसेंड कर दीजिए ना, डाउनलोड नहीं हो पा रहा है।
रीसेंड करना है, रुको एक मिनट। अच्छा, नानो मटेरियल का पीपीटी कहाँ पे? I'm not good at actually organizing things. मुझे भी देख के देना होगा। मुझे थोड़ा टाइम दो, फिर मैं ढूंढ के दूंगी। एक मिनट, भूल जाऊंगी बेटा। अभी दे देती हूँ नानो मटेरियल का पीपीटी। Nano Materials. My God, I'm not getting what happened.
Someone shared in the group.
Ma'am, आप shared one. Once you check, is that the correct one?
आपने शेयर किया है क्या? मैं एक्चुअली, मेरा क्या है ना, अभी मैं क्या कि सी ड्राइव में बहुत ज्यादा डेटा था, तो मैं उसको सारे डिलीट कर दी। प्रॉब्लम हुई है, और उसमें एक इम्पोर्टेंट फाइल भी चला गया। मुझे और एक बार बनाना पड़ेगा। आपने व्हाट्सएप में भेजे हो क्या? व्हाट्सएप में भेजे हो?
यस मैम।
लेकिन मैं व्हाट्सएप
यस मैम
ओपन करती हूँ ये लैपटॉप में। हाँ, यही होगा शायद। हाँ, यही होगा। ये मैंने पहले से दिया था क्या? देख लेते हैं, एक मिनट।
Yes ma'am, you only send this.
हाँ, यही होगा। क्लासिफिकेशन ऑफ नानो मटेरियल्स। हाँ, ठीक है। हाँ, यही होगा। सिंथेसिस, टॉप डाउन। टॉप डाउन में बल्क मटेरियल को आप छोटा छोटा बनाओगे, बॉटम में छोटा छोटा करके नानो फॉर्म को लाना है। हाँ, ठीक है, यही है। ठीक है आयुषी, थैंक यू। इसमें ज्यादा कुछ नहीं है। और एप्लीकेशन में क्या है क्या? हाँ, कोटिंग। हाँ, ये है तो ठीक है, यही है। थैंक यू आयुषी। अच्छा, ये आप लोग को मैं ना क्या कि क्या बोलती हूँ। अच्छा, मेरा मेंटर ग्रुप में मैं लिंक और रजिस्ट्रेशन लिंक और जो क्या है फ्लायर भेज दी हूँ आईपीआर अवेयरनेस का। अगर आपका दिमाग में कुछ इनोवेशन का आइडिया है तो हाउ यू विल प्रोटेक्ट योर आइडिया, उसके ऊपर एक अवेयरनेस प्रोग्राम है गवर्नमेंट ऑफ इंडिया का। तो कुछ है ना 75 ईयर्स ऑफ इंडिपेंडेंस अमृत महोत्सव, उसके लिए वो सेलिब्रेशन हो रहा है। तो अगर आपका लाइक इफ यू आर इंटरेस्टेड देन यू कैन ज्वाइन फॉर 1 आवर। ओके, तो लाइक मैं अपना मेंटी ग्रुप में भेजती हूँ। आप लोग का जो अनऑफिशियल ग्रुप है उसमें कोई भी मेरा मेंटी भेज देगा। अगर आपको इंटरेस्ट है तो आप ज्वाइन कर लोगे। उसमें आपको सर्टिफिकेट मिलेगा गवर्नमेंट ऑफ इंडिया का। ठीक है, हाँ मैं भेज दी हूँ। उसमें कैपेसिटी है 1000। अगर आप लोग का कोई फ्रेंड भी ज्वाइन करना चाहते हो तो भेज सकते हो। 1000 स्टूडेंट एंड फैकल्टी मेंबर्स दे कैन ज्वाइन। और एक्चुअली ये था कि सारे यूनिवर्सिटी का एक एक स्कूल को लेके ये करना है, लेकिन स्टार्टिंग में हम डेंटल, मेडिकल एंड किट इंटरनेशनल स्कूल एंड एसओटी इसी को लिए हैं। एसओटी मतलब अप्लाइड साइंसेस। अब जो मैंने बोला कि मेरे सेक्शन में अगर कोई इंटरेस्टेड है तो दे देना, क्योंकि सर्टिफिकेट तो हम ही दे देंगे, आईपीओ मुझे देगा और मैं डिस्ट्रीब्यूट कर दूंगी। अब जो जो रजिस्टर करेंगे उनका ईमेल में पहुंच जाएगा। ठीक है, दिस मच ओनली। और नैनो मटेरियल में मुझे नहीं लग रहा है कि मुझे पढ़ाना पड़ेगा इसमें कुछ। नैनो मटेरियल क्या है, कितना टाइप का है, तो और इसका एप्लीकेशन